So first, thank you all for joining us today. I know that there are several events happening at the same time. And for everyone who asked for the recording, yes, this will be recorded. And today's topic, which you can see behind this, like a little bit of a clumsy reference, is the topic that has been like resurfacing through every panel discussion that we were having since we started streaming stories. And that is the relationship between batch and stream processing, the evolving relationship between the two, especially with streaming becoming more popular and being more accessible and affordable. So I'm super excited about today's topic and today's guests. And before we give you guys some space to introduce yourself, to tell us a little bit about yourself, your product, and how that fits into like a broader streaming ecosystem, let's just like have some ground house rules. So just for participants to know, Zach, if you can just. Okay. So you can at any time ask questions in a QA tab in Zoom. It's being recorded. Whoever the recording will be sent to them. And if you have any issues with Zoom, just like being Zach or me. So after this intro part, I would like to introduce our participants and actually ask them to introduce themselves and like tell us a little bit about also their product that they're building and how it fits into this like a wider stream processing. So how do you want to start? Who wants to start first?
I can go.
Yeah, go Dave.
Thanks for having me. I'm Dave Yaffe, co-founder of Estuary. So we actually got into streaming through our last business where we found it was difficult to work with both streaming and batch data at the same time, meaning if you wanted historical data and streaming data, real-time data, those two things are difficult to marry due to the way that streaming systems generally work. And we had to build a system for that for our last company. Estuary intends to essentially productionize that. We build production grade data, streaming pipelines and make it easy to do three things. That's capture, transformations, and materializations of low latency data, and to actually productize those assets.
Thanks, David. Vicky, would you like to go next?
Yeah, sure. Yeah, so again, thanks for having me. It's actually the first one I've done under Streamkap. We're fairly new, so all good. So Streamkap is a managed for some background. Streamkap is a managed service of Kafka, Debezium, and so on, providing CDC pipelines and soon to be stream processing. We got into this over a long time. I have a streaming background going 20 years, but the previous company to this actually was a batch ETL company, and we were hearing lots of requests for streaming. And we started to think, okay, can we go to micro batches as an interim step? And ultimately decided, no, we couldn't do that. Completely different architecture. And we're going into streaming. We need to go all in and build a proper streaming platform.
Thanks, Rayees.
Hey everyone, my name is Rayees Pasha. I head the product organization at RisingWave Labs. Some of you may already have seen the introduction and kind of the story behind RisingWave Labs in the last webinar, but I'll try to be brief. RisingWave Labs is a 2-year-old company. Our founder, CEO, Engine founded in 2021. He is a database veteran. He worked on IBM DB2 and AWS Redshift. He saw the potential of streaming as a processing framework as opposed to traditional batch framework, and combine the fundamentals of the goodness that all of the traditional databases bring along with the cloud native architecture. That was kind of the genesis of RisingWave as a open source product. We started a journey as an open source product. We open sourced it last year in April. And then for the last 6 to 9 months, we've been working on our managed service called RisingWave Cloud, sort of the commercial aspect of our company. I'm I have intrinsic interest in this discussion, batch versus streaming, because there's no right answer, so to speak, because it's more about what is your workload that should dictate the choice of the system. So I'm looking forward to this discussion and learning from David and Ricky and learning their perspective. And also I look forward to the questions from the audience, because I think it's really a discussion for everyone to participate.
Thanks, Rayees. This was like, we're like colloquially always like saying like batch versus streaming, but this is not meant to be discussed in this polarized ways. And but I understand that like one of the perspective is that conflicting one. And maybe to kind of like better understand this relationship, we can start by giving an overview of the current state of batch and stream processing. And I don't want to call out people, but David, you had like a series of posts that were very kind of insightful and also very, I would say, impartial. So maybe you're the right person to start this.
Sure, yeah. So I think that the modern data warehouse is brilliant for exploratory analysis, right? It's amazing at answering point-in-time questions. And what streaming is really good at is repeatedly answering questions that you've learned how to productionize. So taking these point-in-time answers and then turning them into data products. And really, like, that's the delineation that I see between the two types of systems. And so batch and streaming, when we talk about, you know, the differences between all these frameworks, really, I think we're conflating a lot of different operations. You know, there's capture of data, and you've probably seen my slide on this that I shared with the internet. Capture, transport, operational transformations, and I think analytic transformations. I look at those four things as kind of the things that we do with data. The first three, to me, make a lot of sense to use a streaming system. You're creating production data pipelines that are really doing what I talked about at the beginning, repeatedly answering, you know, the same questions that you've learned how to ask.
Who wants to be
I think I have a so for me, the batch versus streaming, like what is the strengths, weaknesses, like, is an important question, right? Because at the end of the day, I want to step back and provide a lot of context about how the genesis of streaming as a separate category came about, right? Because for the consumer, for the customer, they're not interested. They don't have a religion about whether I should use a batch versus streaming. They have a business problem that they want to solve. So from that perspective, let's look at why this kind of separation came, and where batch is good and where streaming is good. If you go back a decade or so, you had this whole revolution about big data. Data being an asset, and we should leverage data to get business benefit. And big data was characterized by these 3 V's, right? You always were told, okay, it's about volume, velocity, and variety. And that's how you characterize big data, as opposed to traditional database systems, which were pretty standard. You know, for a long time, all we had was relational databases. But what happened with the big data movement was it put disproportionate attention on the volume aspect. And that's how all of the technologies that were built, what about handling scale, went into batch processing model, doubling down on that aspect rather than the velocity or the variety aspect. And what people realized is we stored a lot of data. We have built this huge 1,000 node clusters and all that. And after that, they still are not solving some of the business problems, right? What they needed was to answer things in real time, the velocity aspect. And that has kind of led to the recent emergence of streaming as a category. And that's where the strength of the streaming systems comes, in my opinion. So if you're asking about strengths and weaknesses, we shouldn't worry about if batch is good or streaming is good. It's more about what are the business concerns that brought us these systems. In the first wave, the batch came because volume was a problem and it became a solved problem. And now we know that the velocity is a problem. You know, how do we address real-time data in a live data so that we can really inspect and address business questions in real time about what is happening. So that's where I think streaming really shines.
That's quite interesting. The thing is that I think, I mean, you've touched upon it, both of you, but it's the volume of data which was a lot of data, but even today might not be, the cost of processing it, the manpower, and so on. And when Spark and Hadoop came along, everyone was like, I've got so much event data, I need real time. And then I know of companies that spent years trying to build these systems out and delivered literally nothing and then see it dismantled. So I think we've got batch because of those issues. But what's starting to happen is we're able to start seeing, and people like Confluent have been a great movement in this, which is, although it's complex, we'll make it a bit easier for you. And I think what we're seeing now is, a new wave of startups that are making it even easier, or at least providing variations to it at a cost-effective rate. And so the volume, now it's case up for me, I think it's like, why would you choose batch if you've got the streaming option at the same price or affordable, and let's say a managed service, or you have the skills already, in which case it's not really a jump. And that's really the biggest problem today. But if you've got like API data, then of course you should stick at batch. But I think ultimately, even producing APIs, is a time-intensive exercise for those vendors. And there's a better way forward, and people are starting to share data instead. So I think we'll see those different systems sort of, kind of merge a little bit.
Maybe getting a little. Yeah, I might jump in. So getting a little bit specific about use cases, because I think we started to get into that. One thing that I see, I think one of the biggest things we're going to see as a trend going forward is we've moved to batch systems, which use technologies like dbt to chain SQL queries together and really create data products using that methodology. And what that's turned out is that doing that over and over, reprocessing the world, a lot of businesses are having trouble with cost from that perspective. So one of the biggest places I see, streaming helping out with some of this is really solving that problem, trying to take these technologies that we've used that we should be really using for answering point-in-time questions, and we are using for creating basically production-grade pipelines, and transitioning them to real materialized views that are answering questions over time at a really cost-efficient manner. I think that's going to be a big trend that we see really, really soon. Other specific use cases that you can't live without streaming are that we see are things like customer 360, where you're trying to have a relationship with a person, and through that relationship you need not just the history of conversations that you've had with them, but recent activity that they've had maybe with your brand and with your site. Things like fraud, alerting, monitoring. These are, things that point systems have developed over years and years that really service those use cases well. But we don't, things like Splunk, right? And I think you'll see a lot of that becoming more mainstream and being able to go in-house as technology develops around them. Finance is clearly one that people care quite a bit about real time. So those are kind of some of the spaces that I think about.
Yeah, I think cost is invariably tied to everything, right? Anybody who evaluates a system, the total cost of ownership in terms of from the capital investment about what is the infrastructure you need to run this versus what is the overhead of OpEx side, right? That's why I think in our case with RisingWave, we, one of the guiding principles is cost efficiency. We always hang our hat on the fact that it's built on cloud native architecture, which means you can scale independently based on your workload needs. And also the fact that we use SQL. So it's like you don't have to train and learn a new language, a new API to be productive. You can get started quickly. So it's important. Also, at the end of the day, just to what David was mentioning about the use cases, the use cases fall into two buckets. Either you save money or you make money. Right? It's very simple from the customer perspective. So when you look at it, like to do both of those, how does this technology help? Basically, that's the fundamental question that each customer would ask.
Or it protects your money. That's another third category we recently discussed. Very interesting one around fraud detection. Okay, so we do you want to say something, Ricky? Sorry.
Oh, no. Well, I can do. I was going to say those use cases we see as well. But touching upon the cost, I mean, I think everyone knows a lot of software vendors are putting their prices up more recently, it seems like, including what was known as a sort of cheaper, more affordable batch solutions. And this is all only going to help drive over to streaming. And then, of course, you've got companies like Snowflake, true cloud native and so on. So all of these companies coming together, working in real time is only going to drive this more forward.
Okay. Do we have a verdict on what are the use cases where streaming outperforms batch? If that's so, maybe we can know. Rayees is doubtful.
No, I think, we kind of, it's, to me, the problem is if you put it in the context of a use case saying, okay, all fraud detection use cases are better done with stream processing, I disagree, because it is not a vertical. You can say streaming owns a certain vertical or a certain type of use case. It has to be the workload characteristics. For example, any workload that requires you to do incremental processing, you have a continuous stream of data coming in. You just don't have a chance to, if you require a snapshot view of what's happening, batch is still your best answer. But you need a continuous analysis of event data as it comes, and you have to provide context of the current coming data with the historical. Then stream processing is the way to go. So to me, it's a more nuanced answer as opposed to saying, okay, here are the 4 use cases, here are the 3 verticals where one is better than others.
I think that's generally right. The only nuance I'd add is, so for example, databases, operational, I think it's pretty clear, and maybe I'm speaking for ourselves, but we can process that faster and cheaper than what we can see batch vendors doing, even like 10-fold cheaper, even some of the cheapest ones. So why would you choose it over the other, even if you only need a snapshot of data, right? It doesn't make sense to me anymore, especially when you're doing CDC. Charging on monthly active rows just makes 0 sense whatsoever. If you're going to go into the API world, of course, you've got APIs, which it just doesn't matter. That data can come daily. If you can process it cheaply, completely agree. But there's, as I think Estuary provide a real-time Salesforce API, for example. And again, that's very useful data, custom relations, and so on, and that comes through. But what we're also seeing is people with ad hoc operational data. So they're relying on batch. They are, they don't have very much volume, but then once every week, there's suddenly 100 million rows or something like that. And then it just doesn't get processed, but they want it processed very quickly once it arrives. So, it's a snapshot for some period of time, then I want it faster. And I think we're going to see that more and more with the AI being developed. It's like, well, I could do with a model of last week or last month, but with this sort of progression that we're making, why wouldn't you just keep feeding in much faster time? So I think the shift to where can streaming be useful and better is increasing in that sense.
So with that space being like increased, do you feel that like and also like in that regard, do you feel that the stream processing market has grown large enough that it can actually capture the attention of enterprises of different sizes? Do we have some like some data on that, or your thoughts on that, your opinion on that?
David,
Sure. I guess I'm going first on all these, so why not? So yeah, the stream processing market, I think I missed a little bit of the question, but I think it was around, the stream processing market being mainstream. And in that way, 70% of the Fortune 500 uses Kafka right now. So it is mainstream, right? Like we already are at the point where people are transporting their data using streaming technologies. And there's many reasons for that. One was the initial gold boom of course, it being exciting and sexy to get into using stream processing. And if you're, an enterprise, you might as well spend some of your money on that. But the reality is that enterprises want to have, relationships with their customers where they can be quick to respond to them. They understand what their customer's been doing with them recently. Another thing that I would, suggest is that stream processing is already mainstream in other ways, as is that we don't even think about, right? Like when you're using a system like Fivetran, for instance, that's effectively a streaming system with a micro batch of 15 minutes to a day, right? That's basically what it's doing. It's coordinating all your data products to be extracted from your source systems and input into your destinations. Maybe not in the most efficient manner, but really the use case is there for streaming, right? All you want is a view of your data from one place to another. And that is clearly something that like every business has. So I think, in that way, stream processing is mainstream. What the difference is like just changing the technologies from A to B to be a little bit more efficient and incremental.
Yeah, I agree. And what we're seeing is, at least, and I had a previous company before this, but what we saw was enterprise was sick of paying, some enterprise was sick of paying enterprise prices and expecting the standard SaaS features from every platform. And I think as long as they, even the smaller, newer companies have, for example, like SOC 2 and other things, then, why not? We don't have to overpay for no reason. So I think, everyone's looking to save money, as we talked about earlier. Everyone would like faster data. But we're also seeing, let's call it like digital natives, right? So newer, modern companies, and they've got the choice to make that decision straight up. So it's not just about cost; it's just I'd like my data faster, so I'll take it. So I think it's actually what we're seeing is at least companies of all sizes looking to save money, move to a faster experience as well, basically.
Yeah, the way I see it is the question is stream process. Can you guys hear me? Yeah. Okay. So has stream processing gone mainstream? So I want to double click a little bit on that, right? What David mentioned about Kafka, from an ingestion perspective, streaming ingestion, that's totally mainstream now. There's no two opinions about that, right? But stream processing is ingestion, processing, storage, and then serving as well. If you really want to be truly, in the stream model as opposed to batch model. So the latter aspect is still in the process of getting mainstream. And I think a lot of the startups that are coming up disproportionately on the latter aspect, like how do we process, how do we actually prepare data for serving without having to stick it into another system? And I think that's where a lot of the emphasis and focus is. And I think if you really want to put it on a like Gartner hype cycle or some sort of a model where we are, I think stream processing has gone through the hype cycle, through the trough of whatever the disappointment, and then we are at the plateau now, where people realize there's no question whether it is this needed or not. Those questions were beyond that. It's now about how do we make it really useful for everyone, and that's where a lot of the newer technologies are about democratizing and using SQL, for example, with you use this not as an exotic new technology, but can stick it into any ecosystem seamlessly. So I didn't have because one of the things I tried to do was collect some numbers for my own business plan about like what is the total market value, addressable market and things like that. In some sense, the major research firms haven't paid enough attention. They've focused more on the ingestion aspect more so than the processing. But I believe in the next 2 to 3 years, I think it'll become commonplace for everyone to have stream processing, the latter part also as part of their enterprise data stack.
Agree. I think also sorry. Yeah, I think we're quite early actually. There was definitely hype, but there was hype for everything, a year ago, right? And we saw these crazy valuations and so on. So I think we're now into more cost control, but I think we're still early in CDC actually. People look at the obvious use cases and people mention fraud or dashboards, and absolutely we see people saying, I do want that data faster, the business wants it faster and so on. But there's other use cases, which I just don't think people are necessarily aware of they could use it for. So there might be caching, there could be, as we know, some of them might be search, full text search. But one of our clients, for example, once they realize they can have real time and so on, they then, okay, we can change our batch stock sync across multiple systems and channels without having to go and buy out a new vendor for doing real time. They can extend these services across. And I think there's just a whole array of use cases coming, which people just haven't really thought about yet. So I think we're kind of, it feels like we've hit the hype of streaming, but actually there's a whole array of use cases, ML inference or whatever else to come to go more mainstream.
Yeah, so being really specific about some of the challenges that people ran into, I think when they first ran at streaming, they realized that working with streaming, it really requires working with a buffer of data. I think that's changing over time, where you can actually, now there's a lot of technologies that are focused on making your streaming processing data also contain history. That's really important. Another thing is stateful streaming has been hard, right? Doing stuff like reactive joins in a streaming context using SQL. I'm obviously talking RisingWave's language here, but that's something that has been classically very difficult, and we're seeing more and more technologies that are allowing us to do stuff like that. Not to pitch our product, we don't focus on the exact same type of SQL as someone like RisingWave pitches. We focus on more event-based SQL, so you're being able to then think about manipulating events of data and being able to do that in a stateful context with history too. So now I think you're getting a lot of options to be able to work with streaming data in a manner that allows you to actually accomplish real workloads in a simple fashion. And that's gonna just keep going over time as more and more technologies focus on that. And as soon as the gotchas with streaming aren't really there, it's gonna be something that is truly mainstream.
Yeah, I think the one thing I want to add is this stateful stream processing. I think that's a real core area, right? Like basically you're trying to move the traditional database functionality upstream closer to where the data source is, like while the data is in transit. And a lot of the conversations that we have with customers is, oh, can we do the joins? Can we do the aggregates? Can we do things that are more stateful and can basically marry whatever the new incoming data with the context that we already built on existing aggregates, for example, on what happened previously, right? So there's continuity in terms of the insights that we provide. So I think that's where a lot of our requirements in the product are going in, like, hey, these are the things we need, because we don't want another system. We don't want like this data pipeline to be too complicated. We want simpler systems that can answer questions, as opposed to one thing does ingestion, another thing does processing, another thing does storage. Like then we would have unnecessarily complicated, the whole architecture. So.
And Rayees, where do you see the sort of customers doing that today? In the database, for example?
Yeah, some of them in the database itself. We give them the choice. Like, and I don't want to do a shameless plug on the product, but the way we see it is, as a product, you have different functionality at different level depending on what the customer's existing needs are. All the need is processing. They can just do the transformations on the fly and then stick it into another existing system because they're probably using it for multiple reasons and they want to use that. But if they don't want to have that extra hop and want to do something right, use RisingWave as a serving layer, for example, do light transformations and have real-time dashboarding, for example, where the latency is like, it's really paramount. Then you can still use that single system out of the box, very simple. And those are probably the unique use cases that we see as our, like in our wheelhouse that we serve customers.
Makes sense.
Okay. If nobody wants to comment on this, one of the questions that we were getting a lot is this question I have to ask you about the possibilities of unified batch and stream solutions. So any thoughts on that?
I mean, I can go first. So this is like right in our wheelhouse, right? Unified batch and stream solutions is literally what we do at Estuary. So we work with both API-based solutions where we can extract data in a non-real-time manner at a cadence, but we also work in a stream processing fashion. So that's happening as right now, right? Like it's already possible. For us, the way we think about it is we think about it as incremental processing of everything, right? So even if you're extracting data from an API, it's more efficient to do that incrementally versus to do that in a way where you're reprocessing the entire world. And they can play really nicely together if they're designed that way up front. So yeah, I think at a very high level, it makes sense. One of the concerns with streaming systems that I kind of always go back to is the fact that streaming systems usually look at the world as a buffer and not a whole history of all your data. And I think it's really important to have a solution for that problem. The thing that kind of allows you to marry the two worlds is that solution to that problem. Being able to work with, plain old cloud storage and with both your streaming system, streaming data and historical data, so that the two can be married. And that's something that I think has been missing from streaming systems for a while. It's the thing that's allowed batch systems to really scale, right? If you separate storage and compute, then you can really really powerfully process your data that is stored in a separate location. So systems like Kafka, for instance, don't really do that. They offload data to cloud storage, but you still have to process it through brokers. And I think that's something that is really important over time that for us to address as an industry. Curious to get everyone else's thoughts on this one, though.
Yeah. Okay, go ahead, Ricky, and then I'll go.
Oh, okay, fine. Yeah, sounds good. Well, I've been on a bit of a journey on this because I had a batch ETL company, and we did a partnership with CloverDX, which was a sort of pretty famous, well, sorry, let's say established kind of on-prem batch ETL tool. So not cloud first, but we did a lot of work with them, and we supported a lot of connectors. And it worked, and we got customers, and we sold that business, and that was great. But supporting it all is extremely costly, is what we found. And so it's not a case of we shouldn't unify it, we should. But we found that the APIs are just breaking all the time, constant updates, driver issues, and so on. And when we went, and we did look into micro batches and so on, and that just creates another world of issues as well. Anything that's on a schedule and a run, trying to run per minute, 2 minutes, and so on, you just encounter a new set of issues. So in the end, we decided to, we wanted to get into streaming, so we decided to move along. And then when we set up Streamkap, the Cap part is actually referenced to Kappa architecture, which is all about trying to get it all into one. But we've decided just to focus on streaming only. And probably our belief is that there's a lot of established batch vendors. It is really difficult and costly, more than people think, to maintain those connectors. And at least our view is probably that, coupled with data sharing, coupled with the established vendors out there, there's plenty of choice already. And so at least our view is to try and just support only streaming connectors in general. So I think it'd be great to unify it, but we made the decision not to do so we could focus more on just pure streaming stability, etc. Found it too difficult to do both.
Yeah, so I agree with what Ricky mentioned in terms of the differences. I feel like the unified vision is more a utopian vision, like, hey, we're gonna have one common thing. It's there's always be separation between, I'm talking from the processing perspective, right? Because the underlying computation model is different for stream processing versus batch, full versus incremental. And because of the way the engines are designed, the tech is designed, it's always going to be different for, and there's how each workload will be addressed by each of the different models. Now, having said that, for a customer, they couldn't care less. So we need to make sure that they get, they don't have, we don't transfer that pain and the differences to them. So there, I think having a common data format, storage layers, data sharing, interoperability in terms of the systems, having a rich library of connectors that allow for both on the source and sync side, so that it's seamless and for a customer. I think those are the things that I see as things that are driving towards making more unified. But I don't believe there is going to be a single system that's going to address all these things.
So to dive into that, one question for you is, doesn't RisingWave have use batch processing for historical data and stream processing for real-time data? Isn't that something that is already in the product?
Yeah, that's why we have a streaming mode and a batch mode, right? So that's what I'm saying. Like you could use a system, but you still have to, depending on what you want to do, right? If you have a historical analysis query, that would require you to actually get data from our object store, load it into memory, depending on how far back you want to go, right? That's different from our continuous query, like a MV you create and that's running continuously, because that uses a different engine model altogether. Where you just process the incremental data of the data of whatever the window that you're processing. So you could, you could have one. What I'm trying to say is, I don't foresee RisingWave becoming a single system that I'm going to pitch and say, no matter what workload you have, stream processing or batch, will address everything. And I think that would be disingenuous on my part. right? We're trying to say we are still focused on streaming. Streaming is our bread and butter. But if you still want to do some batch, we could help. But if batch is all you need, don't come to RisingWave. Go to another system that's built for batch.
So a couple of really specific examples where it's helpful to be able to just automate the change in processing of batch versus streaming. One is just if I'm doing a backfill on a database, and I'm doing a CDC backfill, what I really want to have happen is a whole bunch of batch queries that extract the data from the database, and that instantly joined with the real-time data without me having to think about it, right? Like that's something that I shouldn't, as a user, have to think about. It should just happen. I should think of my world in terms of collections of data that are full and contain history and real-time data. And if we're not doing that as stream processing platforms, we're not making the world as simple as batch processing platforms. And that's a problem, right? Like, so that's the place, that's one specific place I think it's important. Another one is, I'll give you another example of our like Salesforce integration. Our Salesforce integration, Salesforce only makes the last 24 hours of data available through its CDC connector. If you want to have backfills, which of course every single customer in the history of the world does, you have to hit both of those endpoints and you have to seamlessly stitch them together. So those are two examples of like places where batch and streaming in some level, you might still be using two different technologies for the thing, but the customer doesn't care. And you have to make sure that you're providing a product for the customer that they want to consume directly and they don't have to think about too much. There are other places that it kind of can make sense to marry batch and streaming data. And I saw one of the questions in the chat, like whenever we're working with a marketing API product that is generally a batch system, you routinely will want to merge that with operational data and extract that operational data through CDC or through some sort of stream processing. So, you know, those are good examples of like why you would actually do something like that, I think.
I think that makes sense. It sounds like Salesforce is working the same as the the operating databases, where you'll run off two queries in parallel to backfill and stream at the same time. So I think it makes complete sense.
Yep, exactly.
Yeah, I think the last question actually was. Can you hear me now? Okay. I think it looks like there's a lag. The question about challenges of streaming with streaming databases or batch, I think the use case that David mentioned was one, right? It's a hard problem. It's not. I'm not going to say that it's easy to be solved. It also depends on how far back do you know and what are the other constraints involved with such a scenario that would dictate like how close are we. Like even with RisingWave, with the dual batch and streaming model processing models we have, is there a wall between them, or is there a chance that we can use best of both, or how do we actually? It's a more technical answer that an engineer would be probably better suited to answer that, of what challenges we see, because right now it's either or. We have to somehow marry them together, and I think that's probably going to be the next big challenge in the stream processing space.
Yeah, so something that we want to do, we haven't done this yet. I'm getting a little feedback, but we haven't done this yet. And we want to do it is right now when we process historical data, we do it through a stream processing methodology, right? We use streaming transformations, but it would be a hell of a lot more efficient to do that backfill and transform the backfill using a batch system, then seamlessly stitch it together with a streaming system to continually do those real-time updates. So that's something that we hope to do and we hope to get to. But I think it's a good example of like when we have as an industry the most efficient possible products for creating streaming data products. It will do that, right? It will do a historical backfill using a batch system most likely, and then also stitch together a real-time view so that you have an incrementally updated product going forward. Yeah.
One question I see in the chat that I think, if you don't mind, Joanna, I can, Can you give examples of? Can you give an example of use cases where batch processing and stream processing complement each other? I think in terms of use cases, there could be anyone, but where I see they complement each other is more if you have a streaming ETL sort of a workflow where you have continuous data coming, but you have an existing system of analytics, like system of record that you're storing all of the data. They're using stream processing to do the ETL, light ETL, and then stick it into the downstream system to do the actual serving. I think that would be the workload that I think is where they complement each other. The streaming and batch complement very well. Yeah, I don't know if
I'd agree with you.
Yeah, okay.
Yeah, I'd agree with you 100%. Keep your batch system always up to date with the streaming system, and that's a great method of operation.
Do you want to answer other questions, or we should move forward? Okay. So another question that we have been asked recently is the fact that we are moving to the cloud, like our lives are moving to the cloud, has an impact on increasing popularity of streaming, and how cloud native architecture is a better fit for streaming. So what are your thoughts on this?
I can go first. I don't know, even putting David on the spot each time. So I see the cloud is, moving to cloud is an orthogonal question, right? In terms of it is important, but it is, even batch systems are going to cloud. But where I see a little bit of distinction is, if you are an enterprise customer and a traditional, very conservative one, it's more likely you're using on-prem or hybrid infrastructure, especially the systems that are running on top are traditional system built for on-prem infrastructure, like MPPA databases, things like that. There, it's a clear disadvantage for them to even move because these systems haven't been architected to run on cloud. So you cannot take advantage of clouds, all of the cost efficiencies, and other capabilities that cloud infrastructure offers. So from that perspective, streaming as a new system doesn't have that baggage, or like they were all built to, even the processing model is very incremental, very elastic in how you provision resources and how you use resources. So if an enterprise or a customer is embarking on a transformation plan, like, hey, I want to redo my data architecture, and then the benefit of streaming as a first guiding principle for them to use would really come in handy. So not only you're saving the total cost of ownership of your data infrastructure, but also you are revitalizing your data infrastructure itself. You're using newer technologies, you're taking all of the benefits of stream processing, in my opinion.
To add to that, I think, go for it, Ricky.
Sorry, I was going to say, I don't think it's necessarily just about streaming. I think it's everything, right? So we saw that with Snowflake going back quite a while now. Redshift was in the lead by far. It was a great database, but it was an adapted Postgres database in effect. Snowflake claimed they're trying to build that from the cloud up, sort of cloud, from the ground up. So I don't think it's necessarily related to streaming, but it's, there's so many new technologies, and to be able to separate out compute and storage and just very cheap, fast storage and so on. It's just changing everything, not just for streaming.
I think that streaming is really good at connecting systems, right? It's really good at getting a view of your localized view somewhere else. So if you're thinking about going to the cloud, for instance, streaming is the natural way that you would do it, by keeping a view of what you have locally with what you're trying to migrate into the cloud. And in that way, I think it facilitates that potential workload and makes it a lot more possible to do. Then touching on that comment around separation of storage and compute, cloud's superpower, like one of the cloud superpowers is separation of storage and compute. The fact that cloud storage is such an expendable resource is something that you can use and always have access to. That's a really, really powerful thing that you're getting from the cloud. And most streaming systems don't naturally take advantage of that, but I think it's something that that we will have to, as an industry, more and more over time. Streaming has to have a better story when it comes to like how does it directly work with cloud storage.
Another angle I look at it is when it's on the cloud, right? Like you have this concept of edge computing. You have on the edge a lot of devices, and they're transmitting data. There's more streaming data, and I think as we go more to a distributed model where compute is going away from the core to the edge, I feel there's more value for streaming. Especially with the not only you're streaming in the data, you also want to put intelligence into those devices, like in some sort of processing capabilities. Maybe not on a RisingWave database on each of the devices, but I feel in a general trend, I think streaming processing, as we get more with 5G, more intelligence devices, more devices, I feel the value of stream processing as a general market trend will increase over time.
Yeah, I agree with that. I mean, you're right. I mean, the more flexibility there is at source, the more you can skip out all the, or sometimes slow hops to get that data to where you want it to get to. And so that's just going to encourage faster experiences everywhere, basically.
Yeah, that's a really good point. I'm excited for a world where we can connect any device anywhere at any time and do it really quickly. There's no reason that streaming wouldn't be the natural way to do that when it's really available broadly.
Yeah.
Any comments? Any final thoughts? Questions?
One thing I wanted to bring up. I know this may be again kind of related but separate, is I often hear, like, this is based on my recent conference that I attended, where a lot of the questions I got were like, we have this whole new breed of databases called real-time OLAP databases. They address your real-time needs. So why do I need a stream processing system? Why cannot I just use that? And then I don't have to worry about this whole new inheriting, another architecture model, right? I think that's another question that comes up quite a bit, and I think there is some confusion about what the real-time OLAP databases do versus what streaming databases or stream processing systems do, right? They both address the same problem about newly arriving data. How do we process it, and how do we quickly respond to a user query? But how they do it differently, right? In real-time OLAP systems, the emphasis on real-time is on the user query, user issuing a query and saying, okay, I need this answer, ad hoc question I have, and here's the answer I get. And they may leverage the most recent data as opposed to traditional systems that are much more latency driven. But streaming is different. The event semantics, support for event semantics, it comes in with a different perspective, right? The latency is there from the time the event, the original event data got generated, as opposed to when it arrived at the system. So I feel like that's a distinction, and sometimes the distinction is lost in the minds of people. So kind of confused and ask, like, hey, why can't I do this with Pinot? Why can't I do it with Druid? So I would be interested to know what David and Ricky think about that, and if they see the same, if they see any difference in how they see things.
I'd be actually curious to get your thoughts on whether there's going to be convergence there, right? Like, are all these technologies that are accomplishing this similar thing in different ways, are they on a collision course? And will we see RisingWave offering the same types of things, the same type of things that you get from like a Pinot? Is that the future? Like Snowflake's doing that, right? Snowflake's trying to be a transactional database. So why not here too?
Yeah, I don't know if Ricky, if you have anything you want to add before I answer David.
I was actually going to say, well, what's your answer to those questions? So it's very similar, but also, and I think I echo sort of David's sentiment as well. I mean, there's a lot of real-time databases suddenly, and everyone's got to find their own place in the market, right? Same as the streaming engines. I just think ultimately you're going to end up with multiple databases in place, or apps. I don't think there is one database for all. I don't think there ever will be. There'll be some workloads where even if it's real time, you just want very cheap, and it's okay if it's a bit slower access or whatever else. So I think that's my view.
Yeah. So to answer David's question, there's definitely an overlap, right? In terms of what Pinots of the world and what we are doing. But then there's things that we do, and there is also stuff that they do we cannot do, and vice versa. What we can do, like for example, to have processing at a granular event level, like discrete event level processing and live data, that Pinot cannot do. And also with Pinot and other Druid system, they're more columnar, though they're not good at joins, things that are much more a traditional database would be able to do. So if you have a denormalized schema and you have data coming in and it's like very voluminous and you still want to get really quick response, they're good at a much larger scale than we can handle. But if you have more like streams of data, like 10 streams joining, multi-way join, you need to do aggregates on the fly. I don't think they would handle. So we have our own sweet spot and they have, but there's an overlap. So a lot of the conversation I had with the other vendors in the conference was, how do we position? Because we don't want to position ourselves as a competitor, but we say we are like more competition, right? We have some competition, but we also want to cooperate with them. So in that sense, the previous question about where stream and batch, how do they complement? The same thing happens here. So if they want to do some integration, data integration in terms of multiple streams coming and doing some light ETL, that could happen at a streaming database. And then you stick it into a real-time OLAP database to actually do the serving. So that's kind of the model that I feel works best for both systems.
Yeah, that's what I'm sort of thinking, that it'll be different systems for different use cases in a growing market. So I don't think it's really such a problem, but we'll see.
Yeah, that makes sense to me. So joins and stuff before going into an OLAP system and exploratory analytics would then happen in an OLAP system or, a system like that. And that's the way we look at the world as well. Batch systems are great and they should be used for a lot of exploratory use cases. So that sounds good.
Okay, so we have some more questions, and if you don't mind going to Q&A, and perhaps, we can start with the first one. Shall I read it or?
Yeah, I'll take it. I'll answer live. Since the data transfer over the internet, how can we ensure security in streaming databases while we scale? So from a security perspective, it's again, encryption for data in transit. A lot of the infrastructure, it's a multi-layered security. Right? At the infrastructure layer, you rely on the cloud vendor, for example, to provide in terms of what encryption they offer for data in transit and at rest. And beyond that, in our case, at least RisingWave case, we adopted the model of our traditional database, role-based access control. So all of the benefit that you would see with role-based access control in terms of predefined roles that reflect the business priorities, those would be the model I would say, would work, because we don't have to reinvent the wheel when it comes to security, because the enterprises are very well aware, very comfortable with that model, and the same would work even for streaming databases.
Yeah, exactly. I think the problem of getting data over the wire from one device to a place, that's something that's existed forever. It's been solved effectively. Your cell phone does it every day. So I think we can really adopt the same types of practices there. And the question then becomes enterprises and how an enterprise wants to be able to govern their data as well, which I think is probably more of a difficult problem, but a separate concern.
Yeah, so we have two more. We already answered one of these previously in the chat, but we have this one. What do the speakers think about Flink's community effort of unifying streaming and batch, where both stream and batch can be processed in the same way and sourcing types decide underlying implementation?
I mean, I'll just jump in, it's really what I said earlier. It's the same. I think I think I answered it in my opinion on combining batch and streaming. It's definitely the Holy Grail. I'm sure it's coming through, and the Flink community is extremely active. But I just think it's okay to choose the right system for the right job as such, as opposed to we have to go all in on one and so on. So at least in my experience, it's a little bit too early. and we're about to incorporate stream processing into the streaming platform, and we'll be using, Flink SQL for that. But when, the thought of now, all in one just sort of scares us a little bit, and think we'll just stick to the streaming side. But I'm sure they'll put it off. They're extremely active.
Yeah, I think this the previous one of the main questions was about this in our discussion earlier, right? Like, if you try to do too much, you're not going to be good at either one of them. And I think I'm afraid that might be the way, unless Flink community. I mean, I have to be honest a little bit more about the 2.0, what the how it would be different. Like, how are they going to address that? So I don't have the specifics to address, but in a general sense, I agree completely with Ricky that systems have to be built for a model. They cannot do everything for everybody.
So the thing is, I think by the time it's solved, I think a lot of batch API work will be coming away through data sharing and moving to real time. So it will still be useful. There'll be lots of use cases and so on, but it's just a lot of support, a lot of work, I think, rather than just hammering streaming and stream processing.
I don't have too much to add to that. I think that's all pretty accurate. There's trade-offs that have to be made in streaming environments around windowing and all that stuff. I'm not 100% sure how Flink 2.0 is trying to address those, but they're hard to address currently without really running two systems in parallel.
And we have enough time just for the last question.
What can I? Yeah, the last question. I think I'll take that. Streaming databases can be expensive to set up and maintain. How can it be solved? I disagree with the proposition that they're expensive. I would like you to go look at, because I feel like there is the fear of unknown about, like, oh, this new category means more expensive, harder to maintain, all that. So I think that may be more a perception than reality, because I feel like in the workload analysis in terms of head-to-head with streaming systems as well as traditional systems, we've seen that RisingWave, cost-wise is not actually, in fact, it's a net positive than a negative on the cost side. So, but if the concerns are still there, I think the best way to prove that out is through benchmarking, and we're going to publish that going forward.
I'll just add, I think there's no doubt, right? We all know Kafka, Flink, all these systems are hard to manage and install and set up. And if you've got the team and the experience, great. But this is why you see the managed service coming through, because to provide, it is complex, and to provide it well, this is why the reason. I think the Confluence just had their update call and said, growing like crazy, everyone wants a managed service. They want the best system, but they don't want the headache of managing it and so on. So I think any of these companies that, including ourselves, that can wrap it up and make it a bit easier, obviously sits well with a lot of people.
Yeah, and finally, some aspects of streaming are actually cheaper than batch processing. I think where we've probably seen in the past difficulty and expense is around stateful stream processing, not necessarily around like extraction and capture of data. And sometimes those types of issues can be conflated, but even that I think is going to get cheaper very soon.
I completely agree. Yeah.
Okay. So let's end up with this agreement at the end. Thank you, everyone who joined today. Thank you, participants. Thank you, dear panelists. We'll send you the recording. So thank you once again for being with us today.
Thank you.
Thank you all.
Thanks for having us. Take care.
Bye.